This Decomposition Lab has taken our students on an incredible journey into the discipline of science. Our goal was for students to develop deeper scientific understanding while mirroring the work of scientists. Throughout the 12 days we spent in the lab, students became increasingly autonomous and impassioned about their work.
We started the journey by showing students time-lapse videos of rotting fruit and vegetables. Immediately, students were engaged and excited. As a group, we brainstormed questions that had arisen as they watched their produce rot. This was done prior to introducing the idea of working in our school's science lab, where we hoped to answer some of their inquiry questions.
Before unleashing our budding scientists into the lab, we wanted our students to create specific criteria that we could use to assess the quality of their work throughout the process. We constructed a rubric collaboratively using the CSS report card headings: inquiry, knowledge and skills, communication, enhancing and supporting community, and work habits. Based on these categories, students defined for themselves what quality work should look like. This document, which was referenced throughout the experiment, was also used for student self-assessments.
Our final task before beginning was to accurately identify the problem, the variables, and the necessary materials needed to conduct the science experiment. As a class, students compiled a list of fruits and vegetables that they thought would be interesting to watch decompose. On the first day of the lab, groups of 3 were given the opportunity to select their specimen. They'd be using the same fruit or vegetable over the span of 2.5 weeks to observe and document its changes.
Once their group's fruit or vegetable had been selected, students completed individual charts identifying the starting condition of their specimen and making hypotheses about the changes they thought they would observe as the experiment progressed.
Moving.
Each day in the lab, students were expected to complete several different tasks. These included writing qualitative observations about the specimen, focusing on color, texture, size, and smell. We emphasized the importance of using scientific language in order to describe what they were seeing.
It's getting really mushier, and it's going. And there's a whole bunch of maggots that's crawling. There's a whole bunch today.
Why do you think there's more today than there was yesterday?
Because I think the eggs are hatching.
They recorded the internal temperature of the specimen and the ambient temperature of the room.
Yesterday it was 20.6, now it's 21.2.
Why do you think it's getting warmer?
Maybe because of the temperature in the room.
Students used a digital scale to measure the specimen's mass.
So cool. 34.5 grams.
Is that more or less than what it was yesterday?
It so right previous way. It's less.
I'm gonna write it down what the weight is on my sheet, and then and then I have the information. Then I can go back to my computer, write it on my computer. And this is for backup, just in case it gets erased.
Groups also used the built-in camera in their laptops to take a photo of their specimen each day. This provided visual evidence of the changes seen.
In order to collaboratively track the dramatic changes that would be occurring throughout the process, each group was assigned a Google Doc, an online spreadsheet that multiple people can edit and view at the same time. Each group's unique document was linked from our class website, which we also used to post updated information on our work. Initially, the benefit of using Google Docs was that it allowed all 3 students to simultaneously document and record their data on a daily basis using their own unique colors.
We created a column for teacher comments, in which we frequently left the group's feedback in order to help students improve or challenge them to take their work to the next level. Recognizing the power of Google Docs, we also encourage parents to log on to their child's page and provide them with feedback or ask questions about their observations. This enabled many parents to have active and in some cases unprecedented involvement in their child's learning.
As the days passed, specimens began to decompose quite rapidly. Many began to grow mold, and some even became habitats for larvae. Although quite disgusting in many cases, students were more engaged than ever and increasingly eager to burst into the lab and observe their specimens' recent changes. The arrival of creepy crawlers provided further insight into the cycle of decomposition.
So you can just call them all decomposers because that's what they're doing. They're helping decompose your fruit. And if your fruit had, say, fallen off of a tree and landed on the ground, decomposers and insects will lay their eggs on it. They'll turn into larvae, or their larvae will crawl into it and help break down those nutrients to put back in your soil, so plants can, so new plants can feed on it. And also it helps feed when it rots away from the seeds. It helps feed those seeds so new little plants can grow.
Students began asking more questions and made even more hypotheses as to how decomposers play a part in breakdown of materials in nature. Other shocking findings were how some specimens dropped more than half their weight while internal temperatures continued to rise. Almost all students noted changes that they had not predicted. Perhaps most shocking for some students were the differences between identical fruit and vegetables from class to class.
Towards the end of the 2.5-week period, we asked the students to begin writing blogs reflecting on their work in the lab. We provided them with several guiding questions and asked them to assess their work using the rubric we created together. Without exception, student reflections were powerful and insightful. Through metacognition, students were engaged in critical consideration of what they had learned, how they had engaged in authentic scientific work, and established goals for themselves and for their group.
Quickly, but the thing is, this grapefruit, it takes such a long time to turn black.
Our next step was to provide further opportunity for reflection by asking students to create podcasts entitled Being a Scientist. Our goal was to have students recognize all that they had learned about being a scientist while working in the lab.
In this semester of rotting food, we got to see how our tomato went from just a plain ordinary tomato to this gross tomato with mold on and maggots and fruit flies. It was really cool.
Throughout this inquiry, we addressed a wide range of curricular outcomes, including
Further exploring the topic of waste in our world,
applying an understanding of the scientific process,
generating questions for exploration and investigation,
developing relevant conjectures and hypotheses,
becoming familiar with the use of scientific lab equipment,
working independently and collaboratively to develop and carry out procedures, applying modifications if necessary,
accurately recording and organizing observations and measurements,
critically considering accuracy and reproducibility of results,
using computer resources for recording, sharing, and interpreting data,
representing numbers in a variety of ways and with appropriate units of measurement,
calculating measurement values accurate to tenths and hundredths,
describing and extending numeric patterns and relationships,
constructing and interpreting graphs and tables,
learning about how the discipline of science connects to the natural world,
becoming experts on decomposition,
creative problem solving,
improving metacognitive skills through self-reflection, all while learning to love learning.
It looks pretty gross, but it's part of its cycle. Then it's natural for it to do this. So.
What did you guys put in there?
Our avocado. Alfred is going to heaven.